What if a game could be more than a game? What if it's a powerful tool for STEM engagement and project-based learning? This is our concept behind DavinciFlight. DavinciFlight is an aerospace-themed design game where the player uses engineering design, science, and math to take on challenges and missions. The game is embedded with real engineering tools for vehicle creation, analysis, flight simulation, and fabrication. Players are encouraged to build models, to analyze and design their vehicles. Then when they're complete, they can take these vehicle prototypes and simulate them in a flight simulator to evaluate performance, refine designs, and beat game missions. If your designs for gliders and planes are good enough, you can export them to a 3D printer to fabricate and test them. The file format used is supported by nearly all 3D printers. This lets students take on a real engineering problem from the concept generation phase, model it, analyze it, simulate it, and then finally build and test it in the real world. We've designed DaVinci to support both formal and informal education environments. In the classroom, teachers can customize content by selecting any number of 15 to 20 minute missions, each of which target an NGSS or Common Core standard. When used informally, players can progress through the design challenges and levels, learning as they go. Additionally, missions can be constructed as open design challenges for conducting rich, multi-week or multi-month-long design projects. Built-in guides, educational content, and media in the design library support both formal and informal education. DaVinci also supports evaluation and assessment of student designs, as it contains a detailed and flexible system for tracking almost all player interactions. For instance, mouse clicks, page views, loader times, added components, and so on. If you don't know how to do something, there's no worry, because DaVinci includes tutorials and reference guides inside the game, and also through tutorial videos on our website. DaVinci uses a fully customizable geometry, with each component having hundreds, even thousands of parameters. This flexibility allows the creation of an infinite number of vehicles of differing size and scale with customized appearance. In DaVinci, we focus on modeling. Creation and use of engineering models is one of the best ways to make learning connections in math and science. Models can be built from math input and flow control components. More complex expressions can be written directly using the equation parser. In this example, models of kinetic, potential, and lost energy are created, explored, plots are made, and then test data is used to validate the equations. Finally, the modeling environment provides components connected to engineering analysis codes in the back end. This example, analyzers for geometry, structure, mass, propulsion, and control are defined, along with a model for the aerodynamics. All these things are combined and used to analyze the impact of parameters on the lift curve. DaVinci is unique among its competitors for its focus on realism. The data capture capabilities let players qualitatively and quantitatively evaluate and refine their designs. We always use realistic models for the add-on components like propellers, motors, servos, and fuel tanks. This allows a true exploration of parameter impacts, design decisions, and constraints. This is why the parametric geometry is absolutely necessary. To support engineering design, we use real flight dynamics based on nonlinear aerodynamic analyzers. These correctly capture the stability, handling, and stall properties of the vehicles you create. Finally, DaVinci has the ability to export components to a 3D printer for a hands-on build test activity. This is another reason we've gone to great lengths to use accurate tools for the geometry and analyzers. It's so that the designs in the game will behave the same way they do in real life.